Welcome to Builder Buzz by Home Nation, where we bring in builders, developers, and everyday investors to talk about one of America's biggest opportunities, affordable housing. We'll talk about real costs, explosive growth, big mistakes, and tough lessons you won't learn anywhere else. Whether you're building homes, buying land, or just building big ideas, this podcast is for you.
Hello everyone, my guest today is Jakob Bouna with CoPrint Housing. He's in Michigan and he's working on printing houses. It might sound like a buzzword, it might kind of sound like hype, but it's not just a novelty, there's actually some viability behind it. Printing housing, and he's setting out to bring that to the Midwest. Right now, a lot of house printing is in the South, Texas, Florida, even out in California. Not too much in the Midwest, so he's working on ironing out the details, and he reckons pretty soon he's going to have his hands on a $650,000 printer, which is pretty hard to purchase, pretty hard to come by that amount of money. And then he's going to start printing affordable housing for various municipalities in Michigan. That's the plan anyway. Tune in and let's find out where this journey is going to take him.
So I'm Jakob Bouna. I'm a student at the University of Michigan, the Ross School of Business over there. And this all started back before college. So between my senior year of high school and my freshman year of college, I became a loan officer. So I was working at this company, National Mortgage Home Loans, and my uncle also worked there. And one day, I'm sitting there on the phones making cold calls, and he knew I did 3D printing as a hobby. I had done it for about 2 to 3 years at that point, just in my basement, making my own cool stuff. He walks up behind me, grabs me by the shoulders, and goes, "We're going to print houses together." And I had no idea what he was talking about, but it just always kind of stuck with me. So I looked into it a little bit, but I was also, I was just starting college. I didn't think I'd actually be able to do anything with it. So I was like, okay, just a thought in the back of my head. Then I get to university and I'm walking around. There's like this big club fair called Festival over at the University of Michigan. And there's this booth called the Zellery Institute, and they've got this business competition. And I'm like, I could do that, right? So I'm thinking, what's a good business I could run? And I thought back, I was like, 3D printing houses. So I went to the Zellery Institute. I applied to be in the business competition. I got in. And at this point, it's just me and Lily Wingblad. I'm a freshman. She's also a freshman. We're just going through and make this little video pitch, send it in. Goes well, make it to the next round. Do second one, which is a little longer, goes well, make it to the next round. Now when we get to the third one, this is when it all becomes real for me. Because at this point, again, I'm still a freshman in college. We have no formal business experience outside of the little drop shipping schemes I've done at home, right? So they give me this list of requirements, and it's like, we want you to do market research. We want a 5-year pro forma with financials. We want your business plan, your business model, all this stuff. And I have no idea what it means, right? I don't know how any of this works. I don't know how the construction industry works. I don't know how business works, any of it. So from that's when it really started to take off. I would get on calls every single day with as many people as I could, staff members, students, people in the construction industry, anyone who would talk to me for even 5 minutes. And I'd have this list of questions, and I'd just go through and ask them all these questions, and I'd write down their answers. And at the end of the call, I'd be like, hey, if there's anyone else I could speak to, do you think that would be helpful? Just send them my way. That'd be really helpful. And it really worked. So I made it past the third round. Then I'm in the fourth and final round of the competition, and they're asking for a full business plan, right? So there's everything. I mean, essentially, they wanted even like an MVP, right? And at that point, I couldn't provide an MVP because the 3D printers we would need are $650,000. So I didn't have the funding at that point. But I basically went through how one would be created and how we'd go through and do everything. And that went really well. And at that point, that was when I learned that the other teams competing in this competition weren't just single little freshman students. It was actual teams with funding behind them. Some of these teams had 5-6 people, PhD students, master's students, these higher end bachelor students. And I didn't know any of that. I'm just going in with my blind confidence, right? Just
an idea.
Just pushing through because I didn't know any better. But it all worked out. I ended up placing third place there. And that's when a lot of people started to take notice of what I was doing. I got an invitation to go and do another business competition over at Eastern Michigan. And then I had some other people who were there in the construction industry contact me. They wanted to learn more about what I was doing. And it really just, that organic networking, I don't want to say organic because it was a competition, but that networking I got from the exposure I got, that was probably the most invaluable thing that came from that. The business knowledge as well, but then also the exposure. That's kind of how it took off.
So when was that then?
That was 2 years ago now. That was 2023.
So You're finishing up schooling then?
I have 2 years of school left.
Yeah.
Yeah.
So what's your plan from here? You've done some of those competitions. You've spoken with people. Printing, it's $650,000 printing machine. Not anyone can get their hands on that. So what's your plan with what you have?
So right now, I've actually secured a very large chunk of the funding. So the money's not the issue. Right now, I'm working on just the very, very fine logistics of what the business will function like. So of the construction, of hiring specifically is going to be a big one for me, just because it's a really it's very different from your typical construction model, just because you're not just having framers out there or carpentry or a plumber. You need someone who's able to work with the 3D printer, and that's not a skill set you can come by too easily. So the hiring is what I'm focusing on right now. Next year, there is this program over at the University of Michigan where they really just kind of give you funding. They give you mentors. They give you everything you need to fully actually begin operations. And then as soon as that's completed, I've front loaded all of my coursework to the beginning of my college career. So that way, by my senior year, I'll be able to actually go ahead and purchase a printer and start printing houses.
Wow. Okay. Yeah. So literally in a year or so.
Yeah, very soon.
And you're on track for that?
Yes, 100%.
Really? You'll have people hired. You'll have your own understanding of that machine, the one that you want to buy.
So one thing that I've always done is I've always moved a bit too fast for my own sake. With this, I contacted the 3D printer manufacturer that I wanted to over a year ago, before I was ready to do anything. I just started calling up all these companies, acting like I was all ready to purchase a printer. And what I went to them was, I didn't have $650,000 and I didn't know how I was going to get it. So I tried proposing a partnership. So I'd go through the entire call. It's like a 20-minute, half-hour sales call for these guys. At the end, I'm like, so I don't actually have the money to buy a printer, but what we could do, and then I'd propose a partnership where they could give me a printer and I would start kind of like a little branch for them almost here where I live in Michigan. And most of them said no. There was one company that said yes, and that was Constructions 3D. It was actually their North American distributor, Sustainable Construction Solutions. And so they actually weren't fully on board with the idea, but they didn't say no, right? So I've kept up an ongoing relationship with them, and the printer is already, we got finance, everything is all set. I know these guys. As soon as I get the printer, I'd go out for training. I'd bring some of the workers with me to also get trained on the machine. I'm just really working on the logistics is the important part right now. I have 5+ years of 3D printing experience, and if you know anything about additive manufacturing, at least with this style, it all translates really well. You know, the printer I have in the room next to me over here is going to function near identically to a big robotic arm 3D printer.
So tell me the process of actually 3D printing a home.
Yeah, so
you take the printer out to the location. It's done halfway in a manufacturing facility. How's that work?
No, so it's really interesting. So you start with like the 3D model, right? That's the most important part. If you don't get the 3D model right, the entire thing's going to fail. And so it's really cool because now what companies are doing, they're actually using AI where you could take a set of 2D floor plans and it'll generate the 3D model for it. So you don't have to go to some specialty architecture firm or whatever. You can just get any set of 3D floor plans, any set of 2D floor plans and transform them into 3D. So you take the model, you set up all the parameters for the printer. And this is where it gets really specific. This is where your experience is important. You need to know everything about the print, honestly, because there's so many different ways, you know, in between two walls, the infill, it's called. So what separates them? Do you want the design to be like this? Do you want it to be a straight line? Do you want it to be concentric circles? Do you want it to be cubic? All that stuff can change the structural capabilities of the building. There's other things like the feed rate. So the rate at which the printer pushes out concrete, the speed at which it moves. There's another setting where some printers, when they stop on a layer, they actually pull the concrete back in and then go around to the next spot and push it back out. Those are all really important settings that you can look up as much as you want. You can read as much as you want, but you're not actually going to understand how they work until you use them for yourself. And you've messed up 1,000 times just to fully understand what's going on. So that's the start. And then literally it's a printer. It's about half the size of a bus, like a regular school bus. It's in a 20-foot shipping container. You put it on a flatbed truck, roll it out to the job site. It takes two guys, so just two construction guys, 15 minutes. They pull it out of the truck, they set it up. And then from there, you got one guy who watches over the printer. and make sure, everything's going right, all the settings, whatever, everything is going correctly. And then you have two other guys who are there installing rebar installation if you need it, doors, windows, outlets for electrical, plumbing, HVAC, all that kind of stuff. And the entire printing process only takes 2 to 3 days for a typical 2,200 square foot home. Yeah.
Wow. So that's crazy.
Yeah.
How do they add the windows and the doors and rebar?
While it's printing, right, it goes in layers. So basically the way it works, there's two different kinds of printers. There's gantry-based printers, which have a post in all four corners, and then they have an x-axis and a y-axis. Those ones, they work, but in my opinion, that's old technology, just because they take a team of like 7 guys to set up. You need a forklift. You need a day to set it. It's a whole ton of work, and it's got a limited build space. So you can't print anything outside of those 4 corners. With a robotic arm printer, essentially, it's almost like a big front end loader, except with instead of having the scoop on the end, it's got this big robotic arm on it. And so it's on tank tracks, literally, and you roll it up to the job site. You roll it up to a pre-specified spot. You stick out these 4 legs, almost looks like a scorpion. And then this big robotic arm comes over and it starts printing in layers. And so it'll do the layers. And once it gets to the point, let's say where a window has to be installed, it'll do the bottom of the window, it'll do up to the sides, but it won't put the top on. And what happens is a construction worker will go in there, put the window in, and then afterwards, the printer will literally encase the window into the structure. So it's all already sealed. And that's the way it works for the windows, door frames, plumbing outlets, electrical, HVAC, all that kind of stuff. And then same with rebar. Just while it's printing, construction worker will be there, put the rebar right into the concrete while it's going. Same with an insulation. It'll get up to a certain point. You just go in there, you can just pour insulation right in between the walls, and it works out fantastic.
Well,
yeah.
So is this, the concrete mix would have to be a certain viscosity?
Yes.
Is this different from typical concrete?
Yeah, you can't just go to like Home Depot and pour Quikrete in there. It's much more specific than that. It's specifically engineered by like Sika is the company we're looking to use right now. And it's a really hard balance because you have to get the concrete. The concrete has to be liquid enough to be able to pump freely through the printer, but it also has to be cured stiff enough to support another layer of concrete on top of it. And there's that balance in there that's where like the real fine tuning comes in. That's why the concrete is so important. But what makes it so cool is that you can adjust the concrete mixture for whatever needs you have. Let's say you're in Florida and you're somewhere where hurricanes are a massive issue. You can adjust the R value of the concrete so that way the structure is a lot more dense, so it'll stand up to that kind of thing. But if you're in like Texas, where everything is or Arizona, where it's super hot and climate control is the most important thing, you can adjust the R value to make it far less dense, to make the walls more thermally efficient. So you can really just adjust everything, even with weather. If you're somewhere in northern Michigan, like I am, every single year when it snows, all the roads are crowded. Everyone knows the roads suck here. And that's because water gets in, freezes, expands, breaks everything. You can adjust the concrete to account for all of that, which is really cool.
Yeah, Michigan has frost laws with transport. So we try to send mobile homes up into Michigan, like, I don't know, January, February, March. You can't really do it.
Yeah, it doesn't work well.
They won't allow it. You have to wait until the counties lift them. Yeah, so that's cool. So you can change a lot with that concrete, with the mix. Is that something you do on the machine? It's what you do before you load the machine with material?
So
does that company have to do it?
It's something that happens in 2 steps. So the first step is always going to be at the concrete company, making sure that whatever mixture of concrete they send you it's going to be the right mixture. So it's going to have all the right properties. But the second part is actually, adjusting the parameters on the machine. Because let's say you're printing in Texas where it's going to cure a lot faster. Then you have the opportunity to allow the concrete to flow more freely through the printer. But if it's flowing more freely through the printer, that means you have to adjust the outfeed rates on the printer to make sure it doesn't just start pouring concrete everywhere. Right? So it's all this really fine balance that it takes years of experience to gain.
Yeah, it's not like the machine knows necessarily. Yeah. I'm sure it has some parameters in place, but you largely the operator has to be the one who knows, okay, this is going to come out too quick. We need to speed it up.
Exactly. Yes.
Oh. All right. Then my big question is, and I'm sure you've gone through this and you've done presentations and what have you. How do you know the cost of this is going to be affordable? Like, is this something you have to do on a mass production level to make it make sense?
So not in the slightest, actually. That was one of the first big hurdles I came across when I was learning. Honestly, figuring out the financials for this was how I learned about corporate finance and business finance and managerial accounting and such. Basically, what I looked through is I took the average size of a 3D printed wall, which these are all documented things, like how thick they need to be. And I took that and basically just found the volume of concrete that would be, and I took how much the concrete would cost. It's roughly for like a 2,200 square foot house, it costs around $8,000 right now. That's what the price is. Compared to typical timber built houses, framed houses, the wood is getting anywhere from like $14,000 to $20,000 now. And that was from the last time I checked, which was a little while ago. So it's probably higher now. Additionally, so there's like the concrete aspect, and that's your biggest cost for every job is going to be the raw material, the concrete. The printer, it's not ridiculously priced. It's $650,000, which sounds like a lot to a lot of people, but when you consider it as an actual, like that's the vehicle through which your entire business functions. It's not a lot of money. It really isn't. You can make that back very quickly. So you have the concrete. You have all the other basic materials. So you have like rebar, insulation if you need it. You don't always need insulation, by the way. Your windows, your doors, some of your plumbing and electrical outlets, HVAC, all that stuff. It doesn't cost that much. And then the other part is with the architecture. This is where the business model really hit a turning point for me. You can go the route of some people where they say, we're going to do fully custom housing. We're going to use big luxury homes. It's going to look like this new age futuristic dome thing from Star Wars, and you're going to put it in the middle of the forest, right? And you can do that, and you can sell that for $1 million, $650,000. Or you can go the low cost route, which is where we're looking for. So basically, we have a library of a few different sets of floor plans. So that keeps the architectural costs super, super cheap. And let's say you wanted to buy them and put down like a small development of like 12 or 20 houses or something. You'd say, hey, we want to use this floor plan and this floor plan. Great. We already have the floor plan set up. Everything's already set, right? We already have the printer parameters in there for that. We already have the concrete mixtures for that. Everything's already done. All the planning work is done. Essentially, it's like you're ordering. It's almost like you're ordering prefabricated, except we don't have to ship it out. We can just put it together right on site. So then the printer comes and it just lays down the house. Yeah, it's the cost is honestly probably the easier part of all this.
Really?
Yeah.
So why hasn't this taken off then? Why are people still doing stick framing?
It's just the technology is so brand new. I mean, in 3D printed construction in the entire world is only, I believe, 8 or 9 years old from the last time I checked. It was first done in Russia in I want to say 2017. That was the first time anyone had ever put together anything concrete 3D printed. Yeah. So in the US, it's only about 3 to 4 years old. And here, the biggest company, Icon, they used to be Icon 3D, now they're Icon. They do these big developments in Texas. And there's a couple other companies. It's almost entirely done in the South right now. And I'm honestly, I'm not too sure why that is. That just seems to be the trend, but it is slowly moving towards the Midwest. And the technology is just, again, it's so new. And it's such a specialized skill set. You can't just go get trained on how to use a printer and have everything go correctly. Again, it's that you have to have the years of additive manufacturing experience, and you have to have done everything wrong to know what's right. And because honestly, it's not just a set thing. The technology isn't at the point where you can just have like a set of instructions and just press start and it'll work every time. The technology currently is where my printer might function differently from your printer, and I have to be able to read that from the print. I have to be able to look at the house, and if there's like an artifact somewhere, if the lines are wavy or if some parts are thinner than others or if some parts are fatter, I have to be able to understand how to account for that, even if everything on my printer is technically functioning correctly. It's a hard technology to get into.
So you're going to start printing next year as your plan.
Yes.
I would imagine that you're going to have the best luck with municipalities. Because it may be challenging to get a GC or a developer to sell them on this idea, because they're like, we've been stick framing for thousands of years, so we're not going to change how we do it anytime soon. But a municipality might say, hey, look, we need affordable housing and CoPrint Housing. I like what you guys have. Like, can you do 10 houses for us?
So Yeah,
Hmm.
that's the exact line of thinking that I went through over the past in my first year. At first, when I didn't know anything about the construction industry, I was like, oh, we'll be a subcontractor. We'll get a GC to come hire us to do it, and that'll be it. But then I started doing a lot more research. I started talking to these guys. I worked at two different construction companies, and I learned the actual process. I learned how everything functions, how these people are. There's only
Yeah.
so much you can learn from school. Is kind of a thing
Yeah.
that I've come into contact with. I can go to school and I can hear about how, you to your general contractors, and if they do something wrong, then you take it to this step, which is in the contract, and there's this, and it doesn't work like that in real life. It definitely doesn't. It's much more of a
No.
people business. You need to know how to talk to people,
Yeah.
and that was exactly the issue we ran into. Was we weren't exactly sure how we were going to convince a general contractor to switch over to us instead of just doing traditional stick framing, unless it was like a certified business partnership, right? Unless it was like this was a big chunk of their business that they wanted to invest
Yeah.
into. So what we started looking towards was Detroit city government specifically. I had a professor who did a bunch of work on their housing market, and specifically like research reports, figuring out what was wrong, how to fix it. And what Detroit's doing right now is actually super interesting. It's a really good chance for low cost home builders to get in. Basically what they're doing is, when the real estate market crashed in 2008, it hit Detroit especially hard because Detroit had a lot of houses that were going for below $50,000. Okay. And what happened was, once the real estate market crashed, all these houses sold for even less and less and less. And because they were under $50,000, after the mortgage crisis, the government made it really hard to get a mortgage under 50 grand. So nobody was getting mortgages, which just pushed these house prices lower and lower because everybody was buying cash. So we got to the point where people were buying houses for like $2,000, right?
Yeah.
And so now you've got all of these houses who could be bought so cheap that just nobody cared about them. And they would honestly, they would get ruined. You can go down to any city block in Detroit, you'll see at least one or two blighted houses, maybe a couple empty lots. And so Detroit's trying to fix this. So essentially the way they're going about fixing it is they're trying to raise the average home price in Detroit above 50,000, because if they can raise it above 50,000, then that'll allow people to start getting mortgages, which will bring more people into the city because, just honestly, because they're spending more money, they're going to care more about the house. They're going to upkeep it. They're going to want, they're going to want to have a nice quality area. Right.
Yeah.
So what they do, they go into neighborhoods where the average home price is like closer to $40,000, and they pick 10 to 12 lots that are in relative close to each other. I think it's like 3/4 of a mile or something like that. And they build them all up. So they'll build them, or if it's a blighted house, they'll demolish it and put a new house. If it's an empty lot, they'll put a new house. And they'll build them with the goal to sell around like 70 to 120,000. And what Detroit's actually doing is they're building them and they're taking a loss on just about every house they do, and then that's being subsidized by I think it's the Gilbert Foundation. Those are the Rocket Mortgage guys, right?
I think
So that's being subsidized by them. So Detroit's taking a loss trying to get affordable housing back into the city. And I've spoken with I believe his name is Justin Onwenu. I can never say his last name correctly. He's the new director of entrepreneurship and development in Detroit. I've spoken with him. The word he used was light speed. They're just moving as quickly as possible. They're trying to get any innovation they can. I just saw the other day they were working with someone who was using AI to keep home costs down through like design or something like that. And so that's the conversation we're currently having with them, trying to get our houses into these programs. And honestly, you can go to Detroit and just look up the Detroit Land Bank. You can go through there and they have thousands of properties available for like $500, $1,000. It's dirt cheap over there. Yeah. And another thing they do is, because they're in such a rush to get all of this built up, they have these things called developer packages, where basically if you find 4 to 9 plots of land in like relative closeness, I think it's within like 3/4 of a mile again, they will sell them to you at a discounted price, already cheaper than what you're getting them for. They're just really pushing for more affordable housing to be built in Detroit. And it's honestly, it's the perfect breeding ground for this kind of technology.
Wow. So what you have to balance, so what I think of, because printing housing it's a buzzword kind of thing.
Yeah.
But that doesn't mean it's not viable. Kind of like what you're saying, Detroit's working with the guy with AI,
That's a buzzword
reducing
kind of,
costs by AI. That's totally buzzword stuff. Like, in the long run, does that have any sustainability? Like, that gets funding maybe now in the short term because like people like to read an
It's
article
cool,
headline where AI is reducing the cost of housing, and like, whoa. But if it doesn't have any sustainability, it's not going to last. So how do you make sure that printing housing is not just a buzzword, but something that actually has sustainability?
So in my opinion, the way I see things moving forward is 3D printing as a whole, so additive manufacturing, it's honestly, it's taking over almost every manufacturing industry. It's really getting close. So you have things like consumer goods, right? I mean, the printers I have in my house, if I were to have bought those 5 years ago, they'd be $1,000, $2,000, $3,000, $4,000 printers. I bought them for $200. Right?
Wow.
That is just it's
Wow.
so much better at such an exponential rate that everything is getting so much better, and it's getting so much cheaper at the same time. So that's one. So you have like consumer goods, right? So like I like comic books, right? So I like printing out stuff from comic book movies like Batman, Superman, all that kind of stuff. I make those, I sell those. That's a consumer good. Then you can get into like the jewelry market. Almost all custom jewelry nowadays is made through 3D printing. What they do is they use a resin printer, and they make a 3D model of the jewelry, and then they print it in a wax-based resin, and then they use that and they cast it into gold, right? They burn out the wax and they cast it into gold. There's that medical industry. I mean, you see a lot of medical implants now are being done with metal 3D printing because you can achieve certain geometries and structures with a 3D printer that you just can't achieve with traditional machining, right? I mean, there's this one skull implant where it's got like a lattice framework in there, and you can't get in there and machine every single piece of the lattice. And if you could, it would cost 20 times the price. But a 3D printer can do it in a few hours at, a fraction of the price, right? That's what they're doing there. They're printing out the 3D printing rocket parts. I mean, even the food industry, even food, you see online, you see like, oh, there's a 3D printed steak. And while now that seems like a joke, it's entirely possible that they develop the technology to a point where it becomes cheaper to 3D print certain kinds of food, not like a steak or something. I'm not sure who would want to eat those. But, certain processed foods, they could easily 3D print those, especially like candies. There's no reason why they couldn't. They have 3D printable soap. I mean, I can buy a roll of soap filament and put it in my 3D printer and print out a bar of soap. That stuff is getting there. So the entire additive manufacturing sector is just growing at such an exponential rate that there's no reason why it can't take over every manufacturing industry. Now, when you get into the construction industry itself, it's just so fast and it's so cheap. I mean, honestly, when I was speaking with GCs, one of the number one complaints they had is dealing with people, right? They just so many subcontractors, and they're dealing with this guy that doesn't want to do this. This guy's he's got his stuff here. The plumber did something, drywall, whatever. Right? They're all pissed off at each other all the time. Yeah. And so one of the number one ways that 3D printed construction cuts down on that is that it cuts down on the number of people you need to have on a job site. I mean, the average crew for a 3D printed house is 3 guys. You have one guy monitoring the 3D printer, and you have 2, maybe 3 guys if it's a larger project, actually installing the stuff while the thing is going. And honestly, the steps are really simple. You get foundation poured, not hard. You 3D print the house. That takes 2 to 3 days with 3 guys, right? After that, you put a metal roof on top. You get a plumber, electrician, HVAC guy to come and just route those things. They don't have to do much. They don't have to drill into the walls. They don't have to go and mess around with all these tools. They can just route them because it's already built into the structure itself. So no one's going to get pissed off at each other for cutting some wire or doing this or that. It's already all pre-planned. And especially too, because if you have an electrician, let's say on our team, if we're working with one of the 3 floor plans that we have, they already know where everything goes. This is not a new project for them. This is not new plans that they have to go and follow and mess up. They already have done this 100 times, right? So there's that aspect. And then after that, you put in, like flooring, cabinets if you want. You don't have to put drywall or siding. You don't have to do a lot of this other you don't have to do all of that stuff. That's why low income housing as well really works for this, because you can just cut out so many of those other general contractors. And the entire process from starting printing to move-in ready is only about a month. It cuts out just a huge chunk of everything. I mean, forget the cost and the time savings. It just cuts out the amount of people like in half that you need to build a house.
And so this is largely only happening in the South.
Yes.
And it's slowly working its way to the Midwest.
Yes. So right now the big 3 states are like Texas, California, and Florida. It's slowly making its way through the Carolinas. And I believe it. I don't know if they do actual 3D printing yet, but there's a training center for concrete 3D printing that was just built in Ohio. So cool. It's literally moving from the south,
Yeah.
like it started in Texas,
Yeah.
and it's just slowly moving state by state, closer and closer to the north. And we're hoping
That's
to bring
awesome.
it to Michigan.
That's awesome,
Yeah,
Jacob.
thank you.
Well, thank you so much, man.
Yeah.
That's great detail. You know what you're talking about.
Thank you.
It's more than just an idea
Yeah.
that you started with, and you've really grown it into something. And sounds like in a year it can really start to actually be a
For
viable,
sure.
like a physical product.
Yes.
I'd love to follow up with you. I know it's a year away. It seems like forever, but it's really not.
It's not
and
too
I'd
long.
love to see. I'd love to see what you're. That's cool, man.
Thank
That's
you.
really cool. So right now, just to recap, tell me what these stages are. You're looking at hiring someone, training them, and then buying the printer in probably like 6 to 12 months.
Yeah. So next process, not so much hiring like a person and training them, more figuring out the hiring process and how that's going to function. Just because it's going to be really hard. I'm not too worried about finding like part-time construction guys to be on site and to install stuff like rebar, electrical outlets, and all that. I'm more worried about finding someone to operate the printer, just because in the beginning we're not going to have enough jobs or enough printers to justify having someone on full-time, right? So that means we have to find someone part-time. But that also means who's going to want to go and learn how to use a 3D printer and only work a part-time job, So figuring out that balance and how we're actually going to structure employment, that's the next step. And then if we figure that out and I'm nearly finished with school, then it's go get the printer. I already have 2 separate people, so the Detroit City government and one other company who are interested in our stuff, send out bids to them. Hopefully they get accepted and then start construction.
Awesome.
Yep.
That's great.
Thank you.
So I'll follow up in a year, man.
Yeah, sounds
and
fantastic.
we'll have you back on. I'm not
amazing.
kidding, man. I'd love to see it. I'd love to hear that. Yeah, we won a couple bids. I got a guy full time. Like, we're already in production. You're behind the ball.
That'd be very
That's
nice.
cool.
Yeah, I'd love that.
Thank you, Jacob. Thanks for your time
Thanks for
today,
having
man.
me on.
Yeah, we'll see you.
All right, bye-bye.